Good morning, good afternoon, ladies and gentlemen. Good evening. Welcome to this series of online lessons. If you haven't already, subscribe to the channel and leave a like for this lesson. Now, this lesson is brought to you by Jennifer, all the way from Nigeria. A big shout out to Nigeria. It's good to see you watching. Now, in today's lesson, we are going to look at this experiment and we'll just basically focus on how to draw a graph. So I'm just going to peruse through what this experiment was about, then we'll go into the drawing of the graph. So the aim of this experiment was to verify Snell's law using a parallel side glass block. So what we needed is a refractive glass block, plain sheet of paper, drawing board for optical pins, and a ruler. Methods: place a pin. All right, so basically we are placing pins in front of a glass block, and we are trying to see where it will be refracted on the other side of the block. So you place the pins at different angles, then you check how it will be reflected on the other part of the block. So this is basically the idea here. Okay, so now the instructions were that the pins should be placed at these angles: 30 degrees, 40 degrees, 50 degrees, 60 degrees, and 70 degrees as your incident angles. Okay, so these were your incident angles, and now you are asked to get the refracted angles, or the refracted angles from these reflected. So you check the pin through the glass and you get these angles here that are here. So for 30 degrees the refracted angle is 10 degrees, for 40 degrees the refracted angle is 15 degrees, and so on and so forth. Then now what we do is, this is sine I, so sine of these incident angles. So sine 0.5 degrees, sine 30 gave us 0.5 degrees, sine 40 gave us 0.64 degrees, sine 50 gave us that, sine 70 gave us that, sine, and so on and so forth. Then we do the same for the refracted rays, or the refracted angles. So sine 10 degrees gave us that, sine 15 gave us that, sine 23 gave us that, sine 25, and so on and so forth. So after filling in this table, we go on this question, which is my interest in this question. So you're asked to state Snell's law. So Snell's law says that the ratio of the sine, so the sine of the incident angle over the sine of the refracted angle is constant. Okay, let me write that somewhere. Let me see. Okay, so the sine of the incident angle and the reflected angle is constant. So basically that's that. Or in other terms, this formula as the reflective index of one side of the incident times the sine of the incident is equal to the refractive index of the reflected side sine the reflected side, or the reflected angle. So this is the Snell's law in simple terms. Now if you check, if we have a medium like air has a refractive index of 1. So if air is incident, then the refractive index of air will be 1. And if we make this subject of a formula, we're going to have the refractive index of a media where the ray is reflected is equal to the sine of the incident angle over the sine of the reflected angle. Okay, so now this is what you have. All right, so now having known that, say the refractive index is equals to sine of the incident over the sine of the refracted ray, we also know that the gradient of a graph is equals to the change in y over the change in x, dy dx. So here, the change in y is being represented by sine of I, and the change in x is represented by sine of r. Okay, so now we know that on the y-axis we should have the sine of I, and on the x-axis we should have the sine of r, and our problem is solved. So on the y-axis we're going to have sine of, so all the values, so here when drawing our graph, the y-axis we have sine of y, so this would be the y-axis, and x-axis will be this one. Okay, so basically this is coming from the fact that the refractive index is equal to I over r. Okay, so here we're asked to draw a suitable graph to deduce the refractive index. So for us to deduce the refractive index, we should have this law in mind. We should have the sine of I over the sine of r there. So the sine of I will be the change in y, so meaning that sine of I is on the y-axis and sine of x is on the x-axis. Okay, so now from there we now just need to take this information on the graph paper. So let me just take the information on the graph paper. Now before you plot your graph, you need to plan for it. So first of all, you check to see what is your smallest value in the y-axis and in the x-axis. Then secondly, check if you have negatives. So if you have negatives, then meaning that your graph type will be more like a plus, so where you have your x-axis like that and your y-axis like that, so that you accommodate for those lines. But in a case where you have no negatives, it will just be an L, so it will be something like that on the y-axis, then something like that on the x-axis. Okay, so now I have made a simple sketch. I know that these, if I were to count this, I would say since the smallest number is 0.5 there and the biggest number is almost 1, I can put my 1 anywhere. So I'll try to space this equally. Say this would be maybe 0.1, 0. No, this would be, I'll count in 0.2s. So this would be 0.2, 0.4, 0.5, 0.6, 0.7, 0.8. What should I, yeah. So that one works, and 0.9. So it works a bit. Let me count it. Yeah, I'm sure it will work out. Let me just change how the graph is. So you need to plan your graph very well. Let me start from the far end here. Let me start from the far end there like that, and down there like that. Okay, so now in the y-axis I can choose this to be 0, and this will be 0.2, 0.4, 0.6, 0.8, 0.9, and a 1 here. Okay, so I'm just choosing a scale depending on these values that are here. Okay, so in fact here these values don't even go up to 0.5. So basically I was supposed to make my I can even make it from, you just choose what best suits for your scale, especially in a case where you've not been given values. So here maybe I can even choose to count in 0.1, since on the X we see that the smallest is 0.17, then 2, then it doesn't go up to 0.5, so I can say this is 0.1, then this would be 0.2, this would be 0.3, this would be 0.4, this would be 0.5. Okay, it ends there. Then you need to find what each of these units are for you to get to 0.1. So for instance, this is a 1, 2, 3, there are 10 here. So what you do is you just say 10 divide by whatever number is there. So this, it will give you what each of these units are. So this unit is 0.01. So they are adding all the way to 10. So if this is 0.1, this is 0, 2, 0, 1, 2, 0, 1, 3, 0, 1, 4, 0, 1, 5, 0, 1, 6, 0, 1, 7, 0, 1, 8, 0, 1, 9, then 0.2. Then 2, 1, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8, 2, 9, then 3, and so on and so forth. Then here I can also choose a scale for the y-axis. I see that starting at 0.5, so I can even start at 0.5. There's no problem. So this will be 0.5. Then I just need to know how I will do it here. So here I'll say this is I'll even say 0.6, just check if they are adding up. 6, 7, 8, 9. I think it will work out. So this will be 0.6, this will be 0.7, this will be 0.8, 0.9, 1 will be there. Okay, then now we can just plot the graphs against each other. So 0.5 and 0.17. So 0.5 on the x, so you start with on the x, which is 0.17. 0.17 will be somewhere 0.0, so this is 0.1, 2, 3, 4, 5, 6, 7. 7 will be somewhere there. 8, 9, 10. So 7 will be somewhere there, comma 0.5. So this will go somewhere there. Okay, so you just check here. If this is 0.01, then you look for 17. So that will be there. Okay, so we go to 0.26. So we start with the x always. 0.26. So 2 is here. 0.21, 22, 23, 24, 25, 26, comma 0.64. 64 will be, so if we need to find how many of these units are for us to get to 67. These are 10. So this is 61, 62, 63, 64, 65, 66, 67, 68, 69, and 0.7. So this would be 26, 21, 22, 23, 24, 25, 26. Is it 2, 1, 3, 4, 5, 6, and 4? So like right here, and 4, it will be somewhere there. Okay, it will be somewhere there. This is 6, 1, 2, 3. That will be a bit up. To be a bit up there. This is 1, 2, 3, 4, 5. Okay, this is 6. Need to be there. Okay, to be somewhere there. Okay, you just need to squint in a bit there. Then we go to this one as well, so we repeat the same thing. 3, 9. So 3, 9 is somewhere there, comma 7, 7. So 3, 9 is there. Then 7, 7. This is 7, 1, 2, 3, 4, 5, 6, 7. So that's there. Okay, then we go to 4, 2. 4, 2 is here, and 8, 7. 4, 2 is here, and 8, 7 will be somewhere there. Okay, somewhere there. So this is what? 1, 2. 1, 2, 3, 4, 5. Let me see. This is 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. Okay, these boxes are not enough though. Somewhere there. So it'll be somewhere there. I'm sure you have a better graph paper than this one. So, but it's somewhere there. So you just mark there. Then you have 4, 5. 4, 5 will be halfway. 4, 5 will be halfway, somewhere there. And comma 8, 7. That's the one we're from doing. We're from doing 4, 2. 4, 2 and 8, 7, then 4, 5 and 9, 4. 9, 4 will be somewhere. This is 1, 2, 3, 4. And 4, 5. 1, 2, 3, 4, 5. Somewhere there. Okay. Then the last one is 4, 8. 4, 8 is at the end here. And 9, 8. 4, 8 and 9, 8 be somewhere there. Okay, 9, 8 somewhere there. Okay, so now after you have your graph there, you can simply draw it. So you see that it starts out straight, then bends like that. Okay, so but you need to just draw a straight line to just meet the points that are in the line. So you try to draw from the first point and you draw the best line that fits, the line that has more points on it. So you see that if I put it here, it will not have many points, but if I put it here, it will have a lot of points close to have 1, 2, 3, 4. So there'll be 4 points close to it. So from here, this one, and that one. So this is the line that best fits. So these could have been gotten due to errors. So after you draw your best fit line, now you just find the gradient, which will be the refractive index. So the gradient is basically equal to the change in y, over the change in x. So we just subtract any two values in y, so that are on the line. So we have this point here, which is this, comma this, and we have we pick any point, say this point here, which is the last one, this, comma this. So basically the change in y will be subtracting the y values first, so that will be 0.5 minus 0.98 divided by same value here on top, 0.17 minus 0.48. So we subtract that and we get our gradient. So after doing that, we get our gradient of 1.5 approximately. Okay, so that would be our gradient, and which is the refractive index of our glass. Okay, so here change in y, you just pick any two y variables that are on the line that you've estimated. So the line, you just draw the line with the points that are fitting the most. So you find points that are fitting the most and that are closest to the line. So those points that are closest will make the best fit of the line. Then here you just pick any 2 points. So this will be your y, x comma y, and this will be your x comma y. So this is the same thing as 0.17 comma 0.5 and 0.48 comma 0.98. So you pick your x1, y1, then this is your x2, y2. Then you punch in the gradient there. So that is basically how you find the refractive index using the graph.